Summit. So everybody listen. Everybody listen. I'm missing so many people. What the hell's going on? Um, oh well. So when they ask you this kind of a question, right? The answer can either be B for binomial, and then N and P are the most important things to know. It could be U for uniform, and then the beginning and the end number are the most important things, yes. Or it could be N for normal, and then mu and sigma are the most important things. Basak, yes. And I appreciate you're including me in that number, so it makes it seem like there's even more people here. I
Can
don't
you,
count.
can you say one more time? Oh, you just wrote it down. Okay, I got it.
Yeah, I don't know. I don't know what's special about today. Is today ditch Zoom class day? Is that what today is on the calendar? Did you? I guess you guys didn't know. I could just be sitting here by myself. I would do the whole lecture, not record it, and then just tell you guys, well, you should have been here. Moving on. Sorry. Now, anything else? Oh,
What's N for?
what's N for? Anybody? The good old Bunn theory of statistics. What is N?
The number of trials?
No.
No. Okay.
Oh, not the little n, right? Are you talking about the little n or are you talking about the capital N?
Capital N.
Yes. So what's the capital N?
Normal.
Normal, good. So you can have a binomial distribution, you can have a uniform distribution, you can have a normal distribution. Are these the only distributions, Jeff? No, they're the only ones we know yet.
And N equals, what is that? That I can't understand that signal symbol right next to the lowercase sigma. It looks like an M.
It's a mu. It was just very quickly written.
Okay, thank you.
So it's really, I mean, what's the two most important things to know about a normal distribution? The mean and the standard deviation, yes? The two most important things to know for a uniform are the beginning and the end number. And the two most important things for a binomial is the number of trials and the probability of success. So this book just likes to identify things like this. This is just this book doing weird things. But these are, I like this. This is fun. This is the way you identify stuff. Let me see. What am I up to now? I'm all the way up to 22 people. Watch out. Testing the limits of Zoom. Anybody else questions or anybody else able to turn their camera on or anything? You guys doing okay? Is today hitting you hard for some reason? I'm sorry.
I'll turn my camera on after the break. I need to jump in the shower.
Oh, okay. Okay.
For everyone's good.
There's another person. Thank you, Andrea. All right. And of course, you don't have to turn camera. Don't worry. I'm not trying to lay a guilt trip on you or anything. It just really, really helps mentally for me to see people. That's kind of like what I like about this job. And that's what I don't get to do anymore. And it's slowly driving me insane. Okay. Any other questions, guys, before we keep going? We are in the middle of a quiz, which hopefully, let me see if anybody is doing it right now, because then I'll kick you out of here if you are. Let's see what's happening. Let's see if anybody is scrambling to close it right now. It looks like nobody is, which is good. I especially love the people that don't come to class and instead do the quiz. I'm like, what the shit? Okay, I like it. Nobody's doing the quiz. Good. Keep it like that. All right. No more questions? You guys are good otherwise? Had a lot of good questions in office hours.
You don't record office hours, do you?
I sure don't.
Since it wasn't recording, I hate to make you repeat yourself. Just it's the 94 B and C. something there. Okay. 94B, I got 0 through 6.
Sure. Yeah. Well, no. I appreciate that though. No, 0 is good. That's good. I'm sorry. I keep going back and forth between types of problems. So there could be 0, 1s. Exactly. Good. Okay. So 0 through 6.
And then for C, it's binomial, and you just give us that answer. Okay, thank you.
Okay.
Uh,
All right. I'm going to assume everybody's okay. Just so you know, I don't know if you've noticed this. Let me point out something to you guys. Let's see. Bam. What is tomorrow? What day is tomorrow?
Wednesday.
What's the number of the day? June what?
30th.
30th. What are we doing on June 30th? Can you guys see?
Submitting our quiz.
Okay, I like it. True, but
Studying for the midterm.
do you see how it doesn't even show up here? June 30th, right? There's no June 30th. It's because I set it aside to be review day for the midterm. I mean, the midterm is going to cover every damn thing up through chapter 5, correct? That's a lot of stuff. I probably will start tomorrow off finishing up whatever we get in chapter 7, and then the rest of the time is going to be devoted to review. So come ready with questions. Come ready with old homework questions that you know what the shit was wrong, or homework you're still trying to catch up on, or questions from the midterm, practice midterm. Come prepared, or we'll just sit here and stare at each other tomorrow because I'm not going to bring anything. It's going to be dependent on what you guys want to talk about. Yes.
Did we decide on a day for the review like study group Zoom?
Not that I know of. I haven't seen any decision, so it's up to you guys.
I'll just check in later.
I thought it was Wednesday, 10:30. That's what
I think Thursday morning got the most votes.
Thursday morning.
All right. That's for discussion later. Thank you guys. So there is the group me thing. I don't know who put it together. If you want to put that up in the chat or something. And I every day I get this question. What's going to happen with formulas on the midterm?
You're going to give them to us?
Really?
Yeah.
Oh yeah, that's right. Damn. I guess I already said that, so I better do that. Yeah. So just like on the quizzes, I'm gonna get. It would be so evil for me to go. Here's formulas for the quizzes, and then midterm you got to know them. It's like holy shit. So of course I'm gonna give them to you. Yes, the formulas. I'm not gonna. Have you guys noticed? I don't label them. I don't tell you what they are. I just give them to you. That is gonna continue. So I don't make you memorize them. I make you recognize them. All right. Anything else, guys? When is the midterm?
Thursday.
What's it cover?
Chapters 1 through 5.
1 through 5. I love it. So it's incorrect on the homework sheet because I changed it. And I don't think it was a change anybody had a problem with. I like it. Is that cool? Anything else, guys? Anything Thursday morning got the most votes. Let's do Thursday at 10:30 a.m. Sure. Okay, got that. So talk to me later about how you want that to work. I don't know. Okay. If you need me to set up so Thursday, yeah, okay, that'll work. Okay, I got scared for a minute. All right, so if there's no more questions, we're going to get back into that normal distribution handout that we were working on together. Let me pull that bad boy up here. Sorry, everybody. You have to my random things in my head. I just let them come out sometimes. Here we go. Strangers in the night, exchanging their clothes. There we go. So we got some of the one. Yeah, okay, we got one done, and we started looking at number 2. So let me put this up here. I should also, dadgummit, I don't want Microsoft Store. Go away. All right, here we go. Alrighty. So this first set of problems was mostly just to make sure you could all read the z-score chart. Yes? And then these two made sure you could read it backwards and forwards. So normally what do you do with the z-score chart? You look up a z-score and you get an area below that z-score. But there will be problems that give you the area and you have to be able to look in and look back out to get the z-score. There it is, Jeff. You guys with me? You guys remember that? I know it's been like 24 hours. I understand. Now, we sort of started, we kind of looked at 2A here. So I really want this to make a lot of sense. Is anybody have any issues at all with any of the problems in number 1? You got to let me know. Let me know now or hold your peace for a little bit. You can always let me know later. It's fine. All right. Okay. All right. So the only difference between problem 1 and problem 2 is problem 1, they all start off as z-scores. So I just have to look on the chart immediately. Problem 2, they're all times, right? They're all in minutes. I have to make them into z-scores, and then it's just like problem number 1. So remember what we did yesterday. I think this is as far as we got. Let me just start over here. Go away. Just go away. Just go away. Just continue going away. Oh my gosh, Jeff, really? I have to get every single one. This one won't go away. All right, let it go. Sorry. I don't know why that one won't go away. All right. Oh, let me take this away too. All right, let's just start fresh. This is the most exciting part of this class. All right, so the mean always goes in the middle of a normal curve. So up here, why is it a 0 in the middle? Because any mean becomes 0 when you make it a z-score. Do you guys agree with me? I could be insane. I could have went totally insane. I could have picked the wrong thing to drink. But is everybody cool with that? You guys? Okay. Because the mean is 0 away from itself. And that's what a z-score means, is how many standard deviations away from the mean. Here, they're not z-scores yet. So what goes in the middle?
33.74.
Yeah, the mean goes in the middle, and the mean is 33.74. And I'm curious about 27.2. I want it less than that. Of course, where's 27.2?
On the left.
Of course, is down here. I love it. And then I want less than, so I'm going to shade that little bit in. Okay, let me stop for a minute. For some reason, I have people just put numbers wherever they want to down there. I'm like, no, it's a scale. It's a normal number line. You got to put them where they go. So now I know this answer should it be big or small or in the middle? The percentage answer I get should it be huge or tiny or in the middle?
Small.
Should be small. See the little tiny, little tiny thing. All right, it should definitely be less than 50%. You guys agree with me? And again, if you don't know that right now, does it really matter? No, you're gonna look it up. You're gonna get the answer, but it's kind of to know ahead of time what to expect. Now, why can't I just go ahead and use the z-score chart right now? Is it normal? Is this a normal curve? Yes. So why not just look the number up and get an answer right now? Why have to do extra work? What's wrong with you, Jeff? What do you look up on a z-score chart? You look up I love you guys. You're all like, I'm not going to say it because you're just being a dork. Yes?
They're times, they're not z-scores.
Exactly. So I have to look up a z-score in the z-score chart. So I need to convert these to z-scores. And then once I do, it's just like the problems in number 1. And I know I said this all already, but some of you guys might know that you say 3 times for almost everybody to hear you. So that's the only second time. Okay. So let's make this a z-score. So z-score, what's the z-score formula?
X minus mean. Divide by standard deviation.
Kick ass. So then what do we know here? What's the data point we're interested in?
27.2.
Good. And then the mean, of course, is the 33.74. And the old standard deviation is up here, 8.63. Holy macaroni, Jeff. What is happening? I don't know. And then I think last time we got, well, you guys tell me what you get. I think I remember what we got.
Negative 0.76.
And sometimes I'll do this weirdness. Underneath these, I'll do this. You see what I'm doing over there?
I like that.
Just to tell you, uphill both ways kind of story. When I took stats, our teacher forced us to draw two different pictures, one with the X scores and one with the Z scores. And I'm like, why? Anyway, sorry. So just underneath, I would put in parentheses Z scores. So how do you get the answer? Sorry.
I got a different number. I don't know
What-
if I
What'd you get?
a negative 1.182.
Let me see if I know what you did. I think I know what you did.
27.2 minus 37.4 divided by.
Oh, 33.74.
Oh my gosh, I'm sorry.
That's
Okay.
right. All right, you didn't make the mistake I thought you might have. You made your own unique mistake. I like. We're one step away from the answer, right? We know what the Z-score is. How do I get the answer now that I know the Z-score is negative 0.76? What do I do? Shit, I forgot to open my Z-score chart. Anybody know what to do now to get the answer?
Do you look for the negative 0.76 and look for the area?
Yeah. Let me see. What do you guys see right now on your share screen? Where?
Positive Z scores.
Oh, good. I don't know where I put my negative Z scores. Well, that's weird, Jeff. What good is that? Past Jeff. Can't trust that guy. All right, where's my negative Z scores at? Oh no. Crap. All right. Tell me what you guys get, and then hopefully I'm gonna find my negative Z scores.
It's 0.2236.
2236, is that what you got? Oh, there it is. Weird. Why is it there? I don't know. All right, so now you see my negative Z scores. I guess, maybe. So let's see what we get. Negative 0.7. So there's negative 0.7 there. 6. So yes, I agree. 0.2236. Let me know if you have any issues finding that. Now, let me address this right now. We are in the nuts and bolts technical can you use shit stage, right? There's a whole other side of this we're going to get to about what the hell does this mean, right? So the numbers you get always mean something. So you know me, I'm going to ask you questions about what the hell does it mean you just did. So what did we just look up? Where is this value, this 0.2236? Where is it?
The area to the left of
Good.
2.
It's this area right there. And
So,
is that what the question wanted? I'm sorry, go ahead.
so does that mean that 22.36% look for a parking spot 27.2 minutes or less?
Yes.
Okay.
22.36% of students would take less than 27.2 minutes to find a parking spot over the course of a week, right? I just added up all the times. You guys remember anybody here went to Grossmont long enough you parked on campus back in the day when we could be on campus? Do you guys remember what it was like trying to find a parking spot? It kind of depends on what time of day. If you're there really early, no problem. If you got there about 10:30, you forget about it. Forget about it. All right. Try to do number 2 if you haven't already. Go ahead and do number 2. I'll just sit here. Oh, interesting. Sorry, somebody sent me a question. Okay. I'm gonna sort of catch up with you guys. By the way, I'm probably too late asking this question, but isn't it kind of obvious that I know the z-score is going to be positive for this? Why is that obvious?
Because it's more than the mean.
Yeah. So pay attention. If you get a negative z-score and you know it shouldn't be, stop and go back and see what you did wrong. We get so many people turn these around or something or do something weird and they don't even stop and go, well, that was wrong. Oh. Oh my God. All right. What'd you guys get for the z-score? Anybody got that?
2.23.
0.23? Is that what you guys got?
Yeah, 2.23.
2.23? Yeah, that's what I got. Cool. So 2.23. So this is 0. This is over 2 steps up, right? That's what that means by itself. That z equals 2.23 means that time, would that be an unusual time to have to take? Yeah, it's more than 2 steps away. So this probability should be very tiny because it's even further away than 2 steps away. Do you guys understand? All right, let me see. And then, of course, when you look that up, why are you going to have to do more work than we did on this one?
Because it's telling you what's below, not what's above.
Good. The chart gives you answers for the below area. This problem wants the area above, right? So I always get people very concerned, or they do 1 minus way too often or something. You only have to do 1 minus if you want to know greater than, because the chart gives me less than. That's all. So if I look up 2.23, well, I kind of gave it away here. I got 9871, right? So 9871. The minute that you look something up in the chart, you drop it right there. And then I go, is that the number again? I can't remember. And then I go, oh shit, it didn't answer the question, right? So the people that don't draw the picture, you guys are going to make most of the mistakes. So you don't have to. I'm not going to take points off if you don't draw the picture unless I specifically tell you to, but you are going to make more of the mistakes. So it's up to you. So what's the actual answer then?
0.0129.
Yeah, you got to do 1 minus that point, make it 9, make it 9, make it 9, make it 10. Yay. Did anybody do the shortcut? And you're kind of laughing at us for taking so long?
Are you going to tell us the shortcut?
Sure.
Isn't it the negative on the other side for the
2.23.
Yeah, if you look up negative 2.23, you'll actually get this answer directly
Oh yeah, I remember that from yesterday.
because of the symmetry of the picture. Yeah, and if you don't quite get that, never do it. Right? Sort of like how I feel about blinkers on a car. Have you ever been behind somebody, the blinker is going this way and they change lanes the other way? And you're like, what? Just stop using blinkers. Just stop. It's better if you just don't. All right, that's my rant. I'm sorry. Old man here, got a rant or else I explode. It's old man syndrome. So this guy is going to be a little more work, but it's basically the same thing. So this is kind of like two problems in one. I have two things that I have to change into z-scores. So in the middle goes my 33.74. There's 15.5 way the hell down there. There's 29.5 there. I want to know this area here. The mistake I sometimes see, I don't see it as much anymore, but somebody would subtract these two things, but that's not what the z-score formula says. You actually have to convert both of those into z-scores. So go ahead and do that, and I'll catch up to you again. Oh.
I'm sorry, I think you mentioned this before, but how do we know when we're supposed to use the negative z-score chart versus the positive z-score chart?
All right, this is gonna, all right. Use the negative z-score chart if you have a negative z-score.
Okay.
Or if you have, we'll see them like on part B, we'll see something.
Okay.
All right. Use a positive z-score if you got a positive. All right, so I'm not going to do the whole formula again. We're basically using this formula again, right? So the whole z-score formula. Did anybody do either of these z-scores yet? Anybody?
For 29.5, I got negative 0.49, and then for 15.5, I got negative 2.17.
Ooh.
I don't know how I did that.
I got.
Is it
Anybody gets-
2.11?
Yeah, negative 2.11.
Negative 2.11.
You probably got numbers.
Oh, yeah, I forgot to put the 0.5 in for the 15.
Oh, okay. All right. Now, what the hell do I do from here? So if you look up negative 0.49, it's going to give me too much area, right?
Would you take them both together, find the z-scores, and then subtract the z-scores from each other to get the percentage of the area?
Never subtract z-scores.
Well, not, yeah,
Subtract the areas, yeah.
yeah, the percentages.
Yeah, exactly. So what's the percentage
For
below negative
40
0.49? Yeah.
I got 31.21.
31 point, so 0.3121?
Yeah, 0.3121.
Is that what everybody else got? 0.49. So I agree with that. 3121. You guys okay out there? All right. Now, this is not the most riveting stuff in the world, right? So I'm not asking you to be, oh, but just let me know if this is not making sense. So I got three. So we got 3121 there, and then what's below negative 2.11?
0.0174.
Yeah, 0.0174. And of course, you just have to subtract those two, right? You guys doing okay out there? So I really want you to remind yourself that this is just like finding the area of a rectangle. It's just a much weirder shape. So the z-score chart takes the place of calculating the area of the rectangle. That's what it does.
So it's 0.3121 minus 0.0174.
Yep. Which I think is 0.2947.
Yes.
Yay, Jeff! You could do your
And that
job.
area always has to be positive, right?
Definitely. At least in statistics, for us, the area is definitely going to be positive. Which means, what does area mean in this case? What's another way to reference area? What is area equal to for these kind of problems?
Probability.
Probability, I love it. And we know that the smallest the probability can be a 0. Negative probability, what the hell would that mean? It's so not going to happen that it doesn't happen in the next universe over. It's like, well, I don't know. What? Okay, sorry. I watched too much Rick and Morty. So as promised, there's something interesting about this that related to, I think, a question Katrina asked earlier about when to know which thing to look at. So here I'm very, very specific. I say the 14th percentile. Can somebody draw a line? Tell me where to draw a line that would be where the 14th percentile is.
It would be low.
Yeah, it'd have to be low because what percentile is this?
50.
Yeah, it's the 50th percentile. So the 14th percentile has got to be down here somewhere. So there's only 14% there. Do you see where I wrote the 0.14? Doesn't that look like a z-score? Little jackass, right? I love it. Oh man. But I mean, do you agree with me? It is a little jackass. The stupid little thing looking like a z-score when you're not really a z-score, you suck. So you have to help yourself out. You're going to look 0.14 up like a z-score and you're not supposed to. It's not a z-score. It's not a tuma. It's not a z-score. It's an area. So where am I going to look? Well, first off, will this answer be a positive or negative z-score? Obviously, it's going to be
Negative.
a negative z-score. I love it. So I'm going to look at the negative z-score chart. And I'm going to look up, I'm not going to do, I'm not going to look at negative 0.14, something weird, because it's an area. So what's the closest you can get to 0.14?
Negative 1.8.
Negative 1 point. Negative 1 point. Say again.
Oh,
No, 1.08. There it is.
Oh yeah.
Yeah, careful. So negative 1.08. Do you guys see that? That's the closest I can get to 14%. Pretty damn close. Pretty good for me. So then negative 1.08. All right, so does that answer the question? Does that number answer the question?
no,
Hell no, why not?
because it's not like a time. It's not
Good. If it is a time, that means that you found a parking spot a minute and 0.08 before you started looking for a parking spot, which is a neat trick. So how do I convert that back into a time? Well, let's do a little algebra. Oh yes, Jeff. This time period. I don't know. Today's been crazy. This class has been so exciting so far, Jeff. Let's add in some algebra, make it even better. I'm sorry, my joke flew. So here's the z-score formula. Can you guys, have we done this already? Can you solve that for x?
If you work backwards, put the negative 1.08.
Oh, stop. No, stop. We're going to be better. We're going to make it so we do it once and we never have to freaking solve for x ever again because we're going to have another formula we're going to create from this one. So this formula works beautifully the way it's written. If I know X, I know mu, and I know sigma. I do know mu, I do know sigma, and for this problem, I know Z. Are you guys with me? And what I want to know is X. Can we just solve this thing for X so I never have to solve for X again for this formula? How do I solve this for X?
Is it mean plus?
No, don't tell me what the answer is. Tell me how to. So what's the worst part about this formula? Besides there's no numbers. What's the worst part of this formula?
The division.
Division, that sucks. What's beautiful is in algebra, the best way to look at solving equations is if there's a part you hate, kill it. Now this is not a life lesson, kids. If you're not careful when you're teaching math, you can create a bunch of psychopaths. So none of you become Dexter. Just stop yourself. So how would I kill the sigma? How would I kill this sigma? What would I do to both sides to kill
Multiply
it?
it.
Multiply.
Multiply it. Stop being a freaking fraction, you freaking crazy. Get out of there. I love it. I'm using very technical language right now. I'm sorry. I'll try to. Yeah, Dexter was awesome. So now I'm at Z sigma equals. Now for some reason, some people have this thing that survive. Isn't he dead? He's dead. He's totally dead. So he's not still there. And then I'm one step away, and then we'll catch up with what you were trying to tell me earlier. What's one more step?
Plus
Add
the
the
mu.
mu.
Add the mu. Add the mu. So let me write it again. So X equals mu plus Z. I'm pretty sure we did this, didn't we? I can't remember. I'm almost certain we did this because I remember pointing out, and I could be thinking about last semester now, dang it. Do you guys remember the one question I'm going to ask you on everything on the midterm and the final? Do you guys remember what that question is?
What's the Z-score, or what does it mean? in
What does the
words?
Z-score tell you? And watch this. You ready? The Z-score tells you the number of standard deviations from the mean to the data point. So formulas are sentences. You can translate them into English. And grammar is often a problem, as anybody who knows translation between languages understands. But this translates really pretty well. The number of steps, the number of standard deviations from the mean to the data point. So what can we do with it right now, Jeff? What does X represent in this problem?
Data point.
And what are the data points known as physically? What are they?
Time?
Times. And isn't that what it wants from me? Yay! So if I use this formula, it will convert the Z-score we got into a time, or something we call a raw score. We call this a raw score because it hasn't been processed into a Z-score. So let's see what we get. X equals the mean. And of course, it's going to be Z-scores minus. Are you guys cool with that? So minus 1.8. And does that make sense? Don't I have to go below the mean? So am I not going to start at the mean and go down this many, what was it, steps? 8.63, I think. So that's using this formula right there. So that's how to convert a Z-score back into a physical raw score, whatever the situation is.
Can you repeat what X means one more time in plain English, please?
Did I not use plain English before?
You did. I'm writing
Okay,
everything.
okay. So as always, X is the variable. What is the variable in this problem? Time. And what's the question want? Time. That's why it makes sense. I'm going to use a formula that solves for X. So when I plug all my stuff in, I'm going to get X. And in this problem, X is the amount of time.
So X equals the mean plus the number of standard deviations.
Yes. Times the standard deviation. So Z sigma U. Right here. So this is a formula that will be on the formula sheet on the quiz for this chapter. Okay. And then what do you guys think? Sorry, go ahead.
How did you get negative 1.08 again? I think I missed that part.
Oh shit. All right. 14th percentile So that means there's 14% below the z-score. So if I look up 14% in here, that's 14%. So it's below what z-score? It's below a negative 1.08 z-score.
Okay, so it's just finding the closest thing to the percentile.
Yes. And how do I know that I'm starting in the body and looking out? Because it's an area that I'm given. It's a percentage. It's an area. So that's how I know to start in the body and look out. I want a z-score. Okay. All right. Okay. And then I don't know what that is. What is that?
I got 24.42.
Sounds about right. I don't like that it's palindromic. Palindromic. Like race car. 10 animals slam in a net. Something like that. 10, anyway, sorry, there's a whole sentence in it. All right. So that's the basics of z-scores and the z-score chart and normal distributions. What time is it? Oh, it's a little early to take a break yet. So let's do this. I have two options for you. I've got another practice sheet that basically just has more questions like this one. Do you want to look at that one? And it's about rent. And I think, let me see, I'm probably joking. No, I think it's about bone density. So that's very different. Let's find out what this one is. Always get rent and bone density mixed up. All right. Oh, let me become a student so you can see exactly where this is. If you go to unit 6, it's called even more normal distribution practice. Oh, let's see. Oh, it is about rent. All right. So I guess the bone, oh, that's right. The bone density is later. Okay. So this is about rent in a district of New Zealand and rent in San Diego. And just to really slam it in your face that we're living in an insane area as far as I'm sure you guys can agree. So that's where that is. So let me do this. I'm going to open it a better way, and then we'll work on this. I'll go ahead and let you guys get a head start. So can all of you access this? All right. Is there anybody that can't access this? Okay. All right. See what happens if I do this. Let me open this up. Donde. Even more. Okay. There it is. Ah, there we go. So I included a link. I don't know. This has been a couple of years now, so I don't know what it's like still. I wouldn't mind living down in New Zealand, living in Lord of the Rings land. See if this is still works. Oh, what do you know? There you go.
For A, would we put it as 930 is less than X greater than X is greater than 930 and less than 1,200, or would it be like greater than or equal to? Because
Oh,
it says between.
I love it. I love it. I love it. All right, now just I really, for some reason, I love that question you just asked. Now hold on. Let me answer one question in chat by asking a question. What group homework? What are you talking about?
Sorry?
No, in chat, somebody was asking me about group homework. I don't know about group homework. What's group homework? So if there's not a place to submit it, then you don't have to turn it in. So stuff we do together in class, you don't have to turn that in because I post the answer key. So don't give that to me. I've got enough stuff to look at. So real quick, do you guys remember for any continuous distribution, what's the probability x equals something? For any continuous distribution, what is the probability equal to? Right, here's a continuous distribution, here's a continuous distribution. What's the probability equal to? Come on,
One?
the area of something, right? And so if I said what's probably x equals 1,000, and of course you're making kind of an assumption here that it truly is continuous, this would be 0 for truly continuous. So there is a little bit of an assumption I'm making about we're pretending like the prices are actually continuous. So it doesn't matter if you write this as this or this. These both mean the exact same thing, since we're assuming it's normal enough. It's approximately normal. Does that make any sense? Would it add any area? Kind of. So if the area of x equaling something is 0, would this add any area compared to this? No.
No, because there's no crossover. Like,
It just wouldn't add any area. So they would end up being the exact same area. Okay, maybe.
so in questions like these, I guess my natural instinct is to write one standard deviation up and one standard deviation down
Oh, I see.
on the thing. But in this case, you don't need to use that. Really, you're just using the standard deviation to find the z-score, but you only put the minimum, or not the minimum, but like the 930 and the 1,200 on the chart. You don't need to put like plus one standard deviation.
Yeah, that might confuse you because those numbers might not have anything to do with the problem. Is there something wrong with that inherently? No. But does it really help at all? Not really. So is everybody cool with what I've done so far up here? I guess I didn't forgot to. Did anybody get this z-score here for 930?
I got negative 0.2691.
All right, I like it. All right, of course, we always just go to 2 places because that's as far as the chart goes. Be really careful. Don't just chop it. Don't make it negative 0.26. You got to round it, really round it. And then how about somebody else? Did somebody else do the 1200 one yet?
Oh my god, 1.70.
Yes, I like it. So then on the chart, I'm going to kind of keep myself straight. There's 1.70 and there's negative 0.27. So now I know where to put the stuff when I look up the areas. Right. I know this is not exciting, so just appreciate it if you're able to do the steps. That's where we are right now. Are you able to do the steps? Oh no, am I doing that? I totally am doing that. All right, guys, just wait a minute. Can I do this? I think I can. Bear with me. Let me see if I can do this. It's going to be interesting. I know, hold on. I know this sucks. I suck. Everything sucks. All right. Don't worry. What am I doing? What am I doing? Why am I being so weird? I don't know. I don't know. I just think this is neat. All right, there we go. Let's see if I got everything. Yes, okay. So that worked pretty well. I was just using the wrong way to write on stuff. I love it. Sorry, so I had to switch over. I forgot my division signs. There we go. All right, so now what area did you get for 1.7? Did anybody look that up yet? Let's see, 1.7. Anybody?
0.94.
9554, yeah. So this is 9554 here. What about negative 0.27?
0.3897.
0.27. 3897. No, that's 8. We want negative 0.27. So it'll be 3936. Is that cool? Do you see that? Is that all right? 3936. Okay. All right. I like it. I like it. Bump, bump, bump. So then the actual answer is going to be 9554 minus 3936. 64. Let's see. So that'll be 5. What am I doing? I don't know.
Oh my god,
What's up?
5618.
What is
0.56.
1.8? Okay.
Yeah.
Were you say, oh my God, because I'm trying to do it in my head, or just because? All right. Everybody cool with that? All right. So real quick, I mean, the whole thing about San Diego is going to be, see how this is the same problems. I don't think we have to do all of this, but for example,
Well, yeah, I just want to take a picture of that really fast.
I'll post this too. Yeah. We're going to do this problem. Don't worry. We're going to do this problem right here. 95th percentile rent. Where would that rent be on the picture?
Very far to the right.
Yeah, way up here. So it's got a full 95% below it. So then we got to find that z-score. So it's just like the one we just did on the last one where we solve for x. So now we've got this beautiful formula here. So once I know z, I already know mu and I know sigma. So then I can figure out what that rent is. And we'll all have a chuckle. Because it's going to be kind of a small number compared to San Diego, at least. Did we find the z-score yet?
Yeah, I got 1.65.
Oh, here, yeah. So this is a neat one. All right, so I talked about these before. Do you see how 0.95 is right in between these two? Now, what sucks is for some reason the formatting, this other one is so much nicer than negative one. See, the formatting is so nice. I don't know why the poor positive one got formatting bad, but if you follow this line, it's 1645 for an area of 0.95. Do you guys see that? Why does that make sense? Because this is 164 and this is 165. And of course, 95 is right in between the two. So it's 1.645. At the end of the semester, you will know that number pretty well. Some of these show up a lot, and that's one of them. So 1.645. Can somebody tell me what that means by itself? This number here? What does that mean?
The number of standard deviations from the mean to the data point.
Yes, so the data point that is the answer is 1.645 steps above the mean, which is why this formula makes so much frickin' sense. What did we just say? The answer is 1.645 of these above the mean. You left yourself no room. That's awesome, Jeff. All right. I really want that to make sense. Even without the formula, it's just what we would do. We'd start at the mean and we'd add that many steps. That's exactly what the formula says to do. Then whatever the hell that is.
I got $1,192.06.
Yeah, don't forget that 6 cents. I like it. Not the I see dead people, just 6 cents. Not 6 cents. I don't know how many of you guys would give your left arm to pay this much rent here, but that would put you in the 95th percentile in this area of New Zealand. Okay, let's do this. Let's take a break. Today's been really boring, so let's take a break. What time is it? I have no idea. Why won't my clock show up? Here we go. 2:30. It's not bad. So let's come back at 2:50. And let me know right now if you have any questions about anything else. Otherwise, go take a break. Let me see. How do I do this? All right. Let's do this problem real quick. There's a weird little thing that happens on this problem I want you to be aware of. So let's see. So let's draw this bad boy out. Here is the mean. 966.84. And then 1600 is going to be way up there. Right? So we're going to make a z-score out of this. And no, Jeff, you're not going to make a song out of that. I was thinking about Mulan. Here we go. 136.91. Okay, somebody with me so far? No big deal. Same thing as always. Nothing weird yet. But then when you do the z-score, tell me what you get when you get it.
4.62.
4.62?
Mm-hmm.
See, so what, did anybody else get that also? Now what's wrong when you try to find that on the z-score chart? What happens?
It only goes to 3.5.
Yeah, what the hell, Jeff? Sorry. So if you try to look up 4.62, this stops at 3.5. And this crazy chart, and yes, I know I gave it to you, so I can only complain so much, says that it's always 0.9999. Right? And of course, that would be down here. So if we go with what the book says, we would put 0.9999. So what's the actual answer then?
0.0001.
Yeah, and that's not even, so here's what I mean. If it's off the chart, I would accept the answer, in this case, approximately 0%. I really want this to make some sense because at 3.5 standard deviation, if it was 3.5 standard deviations up, there's this much below. But we're at 4.62. There's going to be more down here and even less up here. So just to make it sound like I'm an alien, most humans would call 0.00000 whatever. We would just say that's about zero. That's about a zero. So I would say about 0%. Just a little bit above 0%. So either way, you can either say 0.0001 or you can say about 0%. I'll accept either way for this kind of problem. Okay. All right. So what we're about to do is we're about to, let me just say this. We're about to go to alternate universe Florida. I've no idea how that came off across to you, but what we're about to do is what have we done so far with this? Not much. We haven't done much with normal distribution yet, have we? Can somebody tell me, what do we keep for every probability? Has anybody noticed we keep picking one, like here we picked one bedroom. On this problem, we picked one student, correct? You guys all with me? Every problem we've done so far with the normal curve has involved picking one person or one thing, correct? And of course, what do we normally work with in statistics? Do we normally work with one person? What do we normally work with?
A sample size?
Sample, more than one, right? So then what the hell happens to everything if we're talking about a group of things? All right, so that's what we're about to discuss. And somehow that relates to what I call alternate universe Florida. So let's talk about that a little bit. Let me see. Hold on. Let me turn off my sharing and let me turn off my background. Let me tell you everything I'm doing. Let me wait for this to, okay, there it is. There. All right. Oh, I totally forgot to do this. All right. So this is bad teaching, and apparently I don't care because I'm going to do this anyway. So before we get into the Florida and the group thing, let me just do one thing from chapter 4. I even put it up here on the board to remind myself, and I didn't even look. There's a problem that talks about picking a card. I think it's a face card, and it's like, would you want to do this? And a lot of people are saying no because the probability is so low to win. Now hold on, let me do this real quick. Sorry. Do this so that you can see things better. Okay, it's a little better. Now let me ask you this. Let me just ask you this. And again, this is from chapter 4. So before we get into the next level of normal distribution, let me just do this. What if I ask you to pick one card and you win if it's the Ace of Hearts? So is it very likely that you're going to win?
No.
What is the probability that you're going to win?
1 out of 52?
Out of 52 chance. So what's probably you're not going to win?
51 out of 52.
That's right. So somebody help me out. Make this into a decimal for me. 0.01. I don't know.
0.0192.
Is it?
Yep.
Sorry. I can't. That was a guess, but that's early, I guess. And so this would be 0.9808. All right. So do you agree with me that it's really, really unlikely that you're going to win? Right. It would be unusual to win because it's like below a 2% chance you're going to win, correct? All right. Now listen, there's money involved in this game. Would you play this game?
It depends what the money is
No.
and how many times you can play it.
Is the chance you're going to win very high?
No.
No.
All right, now, so let me tell you this. Miss Fosselman got the right answer. You cannot tell me if you're going to play this until you know what the money is involved and how that interacts with the probabilities. So that one problem, I think it's number 36 in chapter 4, where it says you're just going to pick a card, if it's a face card, whatever, and you're like,
it's
oh, the probability.
but because your likelihood of winning with the money involved, you just got to walk away from the table when you're up.
No, stop. Now, this is just, are you going to play at all? Not you've already played. All right, now listen. What if it cost you 1 cent to play? And if you win, I'll give you $100,000. Are you going to play the game?
Yes.
Yes.
Are you going to play the game like many times?
Yes.
Hell yeah, you play it 100 times and you lose. How much money are you out?
You could play it
$1.
10,000 times.
Sorry, say
$1?
$1, right? So just telling me that you're not going to do something because the probability of succeeding is low is not good enough. In fact, what we've done so far is not good enough. You got to calculate the expected value. So let me ask you this. What if I only gave you $10,000? Does that really change your answer?
No, I'd still play.
What if I gave you $10 if you win? Would you still play? I would. It costs a penny to play, and maybe I'll make $10. Are you kidding me?
Yeah.
So what if I gave you 10 cents if you win?
I wouldn't play.
So what you're doing, without even realizing it, is you are internalizing the idea of expected value. You're like, when am I going to expect enough to get to make this worth it?
It's
That's
not cheap day, okay?
Sorry? Go ahead. Go ahead. It's okay. What's up? What'd you say?
Sorry, I was talking to my husband.
Oh. All right. So I love it. Let me see. Let's make this a buck. Let's make this $1, right? So if I make a little table, so if I win, I get $1, right? And actually, let's be careful. If I win, what do I actually make profit?
99 cents.
99 cents, right? So I'll make $0.99. And if I lose, I lose a penny. The probability of winning is 0.0192, and the probability of losing is 0.9808. So then you do now. I almost don't care what the answer is here, to be honest, because the point I wanted to make to you, that as I changed that number, you were internalizing some semblance of this idea. When have I gone too far with how much money you're going to get back? And you're like, you went over a curb for me. I decided not to do it because my expected value got too low. You can't stop at the probability of winning. Because if I win and get $1 million and it costs a penny to play, I'm gonna play that thing a lot. Are you kidding me? I'm gonna play that thing all day. Are you kidding me? I got a lot of pennies. Put them all in my pocket, come inside, here's a penny. Here's another penny, and just have this giant pocket of pennies. I'm ready. Anyway, I don't know what this answer is. How would you get this answer? You'd have to do x times p of x and then add them all up, right? You guys with me? So this is what you have to do. This is like number 36. You must do this to really be able to answer the question. You can't just say it's too unlikely to win. No, this is unlikely to win, and you guys would play in some situations, so you can't stop there. I don't know what this is going to be. This is going to come out pretty decent, I think, right? Well, I don't know. Yeah, it's going to come out to be about almost $1 expected value, I think. I don't know. I can't do this. I get it. Anyway, do you guys get the point of that? It almost doesn't matter what this answer is, but do you guys get the point? The real immediate point is this is how you do 36. Okay, all right. Let me erase all this. You guys ready? I'm gonna erase all this. I was gonna see where the true gamblers were and see if anybody said, is it okay if I use my own deck of cards that I bring? Or are you gonna use your deck of cards, Jeff? That would be good. All right.
Unless it's a stripper deck.
Yeah, we were worried about if something weird was with the deck. Now, the group thing. So instead of picking one person, so go with me on this weird example. Let's say we're in alternate universe Florida. And it's not too different than our Florida, which means it sucks a lot. But it's got a lot of young people and a lot of old people, right? It's got a bunch of young people. So these are ages of people. Got a bunch of young people and it's got a bunch of old people, right? But notice something weird. So let's say this is 0 years. This is 35 years. I don't care too much about my scale, so don't give me any shit about it. This is 50 years and this is 100 years, whatever the scale is supposed to be, I don't care. Right. So what's weird about this distribution of people?
It's not normal.
Sorry?
It's not normal.
All right, but that's okay. That's not too weird. It's actually weird for something to be normal, to be honest.
There's no one between 35 and 50.
There you go. Does anyone know what Logan's Run is?
Yes.
The movie Logan's Run, where you kill people when they hit a certain age. So this is sort of like a weird middling. We just kill everybody in there. All right, anyway, let's not get too Game of Thrones-ish or whatever. So here's my. So how would this have been created? If this had not been made yet, how would I go to this alternate universe Florida and how would I make this picture? What would I have to do? Go with me. Go with me. How would you make this? What would you have to do? What does this show me again? So this is ages of people in Florida. What does this mean? This will be like the relative frequency, right? So most people were either this age or that age. Is that cool? It's bimodal. Can I say, do you guys get that if I say it's bimodal? Do you guys agree? Whatever this age and whatever this age, it looks like they're about the same. All right, now, how was this picture created? What would I have to do if it hadn't been created yet? I would go to Florida and do what?
Like a random sampling of people.
No. This is alternate universe Florida. This is everybody. So I would go up to a person and say, how old are you? And they would say, I'm 97. All right, so I put 97, put a dot there. Go to somebody else, how old are you? I'm 2 months old and I can talk somehow. All right, so then I'll put you right there. Right? You guys with me? How old are you? I'm 37, gotta kill you. You're dead, you can't. I'm sorry. Let me try to be less stupid. Does that make sense? To make this picture, I have to talk to everybody, plot their ages, right? And so that's why they kind of build up. They build up. So there's very few people that have just been born, yes? And there's very few people that are 99, 100. You with me? Okay. All right. Now, what if instead of, in fact, let's be a little more specific. Where would the mean be? Where would the average be?
In the middle?
Yeah, right here, because these would average with these, and so it'd be right there. So let's say the mean is, let's just say it's, what, Jeff? Come on, math boy. Let's say the mean is 42, just because. I'll put it a little bit skewed that way, and plus I like the number 42. Let's just say that. So look now. Is everybody with me so far? This is a little bit weird, I'm sorry, but doesn't this make sense? To make this picture, I'll talk to everybody, put a little dot, and then I build this up. Boop, 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 boop. Now, what if instead I didn't talk to a single person at a time? I got a group of 20 people and I said, what's your average age? And then I put the dot down. Do you guys understand the difference? So this is, I put a dot down for a single person, right? What's your age? This way. What's your age? This way. And now I'm going to say, you 20 people, calculate, talk to each other, give me your average age. What's the most likely average age I would get for a group of 20, a random group of 20 people? You can do it. You can do it. Would it be really likely if I pick a random group of 20 people that I get nothing but 98-year-olds? Would that be likely? Sorry?
I mean, if you went to a nursing home,
Would that be random then?
no.
So every sample I pick, I'm going to pick randomly. Would it be impossible to randomly pick a bunch of 98-year-olds? No. Would it be likely? Hell no. What would be the most likely thing to happen?
You get 42 is the average age.
All right. I can't get any single person who's 42 years old, correct? Stay with me, guys. Come on. I can't get a single person who's 42, correct? Right? Because they don't exist here. Yes? And I'm 48, I would be killed. Here's Jeff, die. So let me just jump to this. The most likely thing for a sample of 20 would be a mixture from here and here, correct? Wouldn't it make sense? What's the most likely thing? I get some young people, I get some old people, right? And the most likely average would be 42, like you said. I don't know if that makes, that's why we call the average the expected value. If I repeat a trial, in this case 20 times, I take 20 people, the expected value is 42. That should be the most common value. Does it make sense that I'll get a mixture of young and old people if I truly take a random sample? That is the most likely thing. So how will this new picture look? So again, I'm going to take a sample of 20. I'm going to calculate the average, and then I'm going to plot the average. Instead of up here, I just plotted X value, the data points, individual people. Right? Here I'm going to plot the average age. So this kind of sucks. I got to push this over, but too bad. So just go with me here. We'll survive. So now it's going to look like this. It's probably going to look something like this. Really roughly, right? The highest peak will be around 42. The next likely thing after a mixture is a bunch of people here and a bunch of people here. That's why there's these two peaks here. Let me stop. This is weird. I understand this is weird. Will it look exactly like this? Hell no. This is just to explain a concept, right? In fact, to be really honest, these would not be that pronounced, but that's all right, Jeff. You'll be all right. Everything's gonna be fine. Okay. Anybody completely not with me right now? Anybody like, what the shit?
I guess just for 42, there's no actual 42-year-old in the group.
Yes,
So how come that's got the highest peak?
because it's an average. So I really want this to make sense.
So it's not like you going through the 20 people and just plotting their individual data points.
Yeah, here I am plotting the sample mean of 20. Yes, so if I get a bunch of young people here and a bunch of old people here, their average will be in the middle somewhere, correct? And isn't that what we just said is the most likely thing, a mixture of young and old? Yes. So where should most sample means occur? Close to 42. So I really
Okay, so
want
the
to get
second chart is plotting sample mean, not data points of ages. That's what I was
Yes.
confused by. Okay.
everything here, every point is not a person. That is a group of 20. That is a person. That is one person I spoke to, right? This is a group of 20 people. I really want you guys to, oh man. Is anybody slightly with me? I love you guys. So every picture we've done, every normal curve we've done so far, this has been a picture of every individual person. Now stay with me. Right? Do you guys understand that when we draw a picture like this, it is all the possible data values. And then I go, well, what about this value? What about 7? How many data values are below 7? Okay, find the area. That's been every problem so far. Above, below, between, all that kind of bullshit. But the picture itself was individuals. Why? Because the question was, what's the probability if I pick one person? Okay, shouldn't that show up in a picture of picking one person? So if the question is, what's the probability I pick 20 people and their average is less than 7? Now it should live in the picture of groups of 20. So every problem we've done so far has been about how individuals are distributed. Individual people, individual rents, individual times of parking. Right? Everybody with me? We are transitioning now into the questions are going to be, what's the probability we pick a sample of 20 people and their average age is less than 7, or whatever the question. So now it's going to be a question about a group of people. This picture ain't no group of people. This picture ain't no group of people. I need the picture that's a group of people, that every point is a group of people. So now if I'm you right now, you're thinking, holy shit, what does this mean for me in terms of work, Jeff? All right, we're getting there. We are still in concept phase, so don't worry yet. You don't know what the work is going to look like yet. Just hang on. Does that make a little more sense? This picture is, I built it by individual people. So then if I have a question like, what's the probability that somebody is less than 7? Then I can just find that area, because that's the number of people that were less than 7. So that's the area less than 7. Are you guys, does that make sense? That's what we've been doing. But if the question is, what's the probability that a group of 20's average is less than 7? Well, holy shit. The picture of individuals doesn't work. I'm not talking about one person. I'm talking about a group. So I need a picture that shows me how groups are distributed. And let me just ask this. Are groups going to be distributed the same as individuals? No, right? You can see an example right here. All right, now let me become a little more concrete for you guys. Hold on. Can you tell me which picture has a smaller standard deviation? What does standard deviation tell you?
Distance of a given data point to the mean.
That's what z-score tells you, and it uses standard deviation to tell you. Standard deviation tells you the average distance from the mean to all the data points. So how do you make the standard deviation big? You make all the data points get far away from the mean, correct? Doesn't that make sense? How do you make it small? Make more of the data points get closer to the mean. So let me ask this question again. Which picture has the smaller standard deviation?
The first one?
The second one, because the peak is in the middle.
Yeah, so let me ask the question in a different way. Which picture has more data close to its mean? The second one, yes? So this standard deviation, whatever it is, we'll call it sigma. We can't call this one sigma, so we'll call it, oh, you're gonna love this shit. This is sigma of x bars. Real quick question, real quick. Stay with me, guys. Oh God, you're hating today, I know. Can you tell me, this is the symbol we use, but can somebody remember, what does the calculator actually tell you when you do one var stats? It doesn't just give you this. What does it say? Does anyone remember?
E.
What? It doesn't just say sigma, it has a little something attached to it. Do you guys remember?
Sigma x?
Yeah, and so and we don't normally write this. We just normally assume it's this, but this means sigma for single data points, right? Do you understand what I'm saying? Sigma for individuals. So the notation we're gonna, oh my gosh. Wait a minute, let me see if I can reset. The symbol we're going to use to represent standard deviation for groups will be sigma sub x bar. Because now these are means. We've plotted means. All right, now, so what does all this shit mean for you? What's the mean of this picture? I basically gave it away, but the mean is still the same thing. You make sure you guys understand that point by itself. If I took an average of people right now, I'm going to get a number, correct? People in this room, people including me. We average everybody's age. I ask your age, your age, your age. What if I took 2 people at a time, took their average ages, and then averaged those? Would that be a different number?
No.
That's right. The correct answer actually is hell no. You're still the same people, right? If I take you 1 at a time versus I take us 2 at a time, why would we suddenly all get older or get younger just because I took 2 of us at a time? Wouldn't we let's take 3 now? That's too much, Jeff. I'm getting too young. Oh. No, so I can't change your age just because I take a different number of you at a time. So of course your average age, all of our average age stays the same. So if I take a group of 20, will that change the overall average? No. The mean stays the same. But does the spread stay the same? Hell no. It gets smaller than what it used to be. So the mean stays the same. The mean stays the same. But the spread, the standard deviation, gets smaller. All right, I'm about to get even more concrete. All right, some of you guys are like, did he get more concrete? All right. So exactly how much smaller does it get? Wouldn't it be nice? Great, now I got this song in my head. Wouldn't it be nice to have a formula that tells me what happens to this standard deviation, right? And not surprisingly, we have one. So I'm gonna erase all this weird ass Florida shit, right? Let me get rid of all this. You're scaring my students. Oh, before I do, one more thing I want to say. Let me get rid of this one. If I were to go to a sample of 31, here's what this would look like. Roughly, not perfectly. So here's the thing. the larger this gets, the more normal this picture gets. Once n is greater than 30, my picture gets normal enough. I warned you about this, didn't I? What have I given you a piece of paper? Have I given you something that has all the answers on it to a certain kind of problem? Some of you guys are like, did you? Did I? Do you have access to something that gives you all the answers to a certain kind of problem?
The Z-score page?
The Z-score chart. And of course, what kind of problem is that? What kind of problem does that give me all the answers for?
Normal distribution.
Normal distribution. So a huge consideration in statistics is when is the distribution I'm looking at normal enough? Why is that such an important thing? Because if it's normal enough, I got all the freaking answers sitting for me on the page, right? So if I have a situation where I am taking a sample and my sample size is more than 30, and I'm asking a question about the sample mean, then it's normal enough. I'm allowed to use the Z-score chart. And let me make sure you really understand. Did the beginning picture look normal? Does this look normal? Is that normal? Somebody chatting at me? No. Is that normal? Is this
No.
a normal curve? No.
No.
Hell no. Hell no. No, 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 no. So that means that I can only use the Z-score chart if I take a big enough sample.
Can I ask a question about that greater than 30? So you're not talking about more than 30 individuals. You're talking about you've taken multiple groups that are more than 30.
Exactly.
Yes.
If the sample I'm taking is more than 30, which means I would be comparing them to all groups of that size, right? So if the sample size I'm taking is more than 30, that means, stay with me, so if the sample size I'm taking is more than 30, that means that the picture I would make, if I did take every group of size, whatever, would be normal. This is weird. Let me ask you this. You ready? Let me ask you this. Every problem we've done, like the one we just did about rents, we said, what's the probability I pick one place and the costs more than 1,600, whatever, right? Did we actually go pick anything? Did we pick anything? Did we actually go look at apartments? Did we actually do any of that? If we did, I missed it, man. And I'm sorry, because I want to go to New Zealand. I haven't been there yet. All right, stay with me. What's that got to do with anything? Stay with me. This is so weird. When I ask you a question and I give you the fact that it's normal. So on a problem like that, didn't I tell you that it was normal? Yes, I told you it was normal. Check. I gave you the mean, whatever that was, 966.84 maybe? I don't know. And I gave you the standard deviation, 100 and something, whatever it was. So I gave those to you. When you draw the picture, you are actually drawing what it would look like if you actually went and did every apartment in New Zealand. How do I know it's going to look like this? Because it's normal. They told me. So I don't have to actually go get them. I know it would look like this if I drew it. If I actually went there and said, how much does that place cost? How much does that place cost? How much does that place cost? Right? Are you guys at all with me? Oh, you're hating life right now. I'm sorry. Oh, Jeff, you can't even make a joke about it. Stop trying. Okay, I'm sorry.
So are you saying if there's a large enough sample size, no matter what we're taking a sample of, it should always have a normal distribution?
Yes.
That just like blows my mind.
I know. Trust me, it probably blew the minds of the people that did it in the first place. So listen.
Is it like that thing you said where if you do something, it'll be like 75%?
Oh, that was something about any distribution, which by itself is freaky as hell. Let's not bring that into it right now, but I know what you're talking about. Stay with me now.
So why does it make sense that there's going to be some number where I get it normal enough no matter what it starts off looking like? Because if I take a truly random sample, most of them will be right in the middle, and then it's going to drop off from there. Now, there's obviously a lot more to this story about why is it exactly 30 that we're comparing, correct? Is anybody worried about that? Sort of like the 12. Remember the 12? Why is it 12? Nobody's asking for that proof, but that's fine. So why is it exactly 30? Because that's what they've noticed. They started with various distributions and they picked sample sizes, and they realized that at around right after 30, everything became roughly normal. Everything became normal enough to meet what the percentages are on the z-score chart. So now listen. I still haven't gotten to what you're going to actually have to do work-wise. So please, we're still talking about concepts. If you're a little lost right now, I understand this is a weird concept. How long has it taken me to talk about this? Quite a bit, right? And you're worried about what the work is. So the work is going to be stupid minimal. It's going to be so little, and you're going to like, why did you talk so much? Because it's a weird idea. Every problem we've done so far, didn't we pick one, whatever, right? Is that 30? That's one. So why were we able to do it? Because the problem told me it was normal, correct? Every problem we've done so far, I had to know this. Yes? Right? You guys with me? Yes. So if it starts off normal, do I need the sample size to save me? No, I know it's already normal. If it starts off freaky as shit, I need a sample size greater than 30 before it smooths out and becomes normal enough. All right, now let's do this. Let me finish up the idea. I've got a concrete as all hell example you're going to hate anyway, and then we'll talk about what your actual work is going to look like. All right. Okay. So if we pick a sample of size n, then several things. The mean stays the same, right? The mean stays the same. That's like taking one of you guys or two of you guys at a time. I can't suddenly make us all older or younger. Our average stays the same. Here's the exact way the standard deviation changes. Standard deviation becomes what it was for individuals divided by the square root of n. So for that one problem with the 20, it would have been sigma divided by the square root of 20. So whatever the standard deviation was that they gave us for individuals, I have to divide it by the square root of n to make it the right spread for groups. So think of this as a formula to take the standard deviation for individuals and change it into a standard deviation for groups of size n. Oh, all right.
Isn't X bar already the sample mean?
Totally.
So then how come you're doing the mean of the sample mean?
Oh, because how many samples of size 20 are there in Florida? How many samples of size 20 are that? You don't have to give me a number. Just tell me. Are there just, is there one? Is there
No,
two?
there's multiple.
There's a lot, right? You with me? In fact, think about Grossman College. How many ways can I pick 20 people at a time? A lot of ways, right? There's a lot of people, correct? Now, this means the average of every sample mean of every sample I could take.
Okay, so instead of an individual being a data point, now you have each sample group being a data point.
That's exactly it. That's what the whole, yeah, that's what the whole picture was, and me putting dots when I was talking to the 7-year-old versus when I was talking to a group of 20 people. I like it. So when I draw this picture, so this is for individuals. If I have a group of size whatever, let's just say 40, and I draw this picture is now Groups, not individuals. This is a group of size 40. This is a group of size 40. So then if I have a question, it says, what's the probability that the average of a group of 40 people is greater than something? Then I can use this to figure it out. I can't use this because that's for individuals. I've got to use the one that works for groups. All right. Notice also what kind of makes sense. As you take a larger and larger sample, what should happen to your average? So let's say the average age of Grossmont is 30. If I take a group of 20 people, could their average be 40 and we won't freak out too much? Yes, we won't freak out. What if I take a group of 3,000 people? Could their average age be 40 and we won't freak out when the real average is 30? No. We'll freak out because it should be closer. So let me see, what's another way to say this? If you went and took one person, if you went out and randomly picked one person and they were taller than 6 feet, would you like excessively freak out? Or would it just be like, huh? Would you freak out and start running around telling people, holy shit, holy shit? If you went out and randomly picked a person and they were taller than 6 foot tall?
No.
That wouldn't be like crazy freaky, but it would be like, oh, that's weird. What if you randomly picked 40 people and their average height was 6 foot tall? Think about it. What would you start to question? Would that be strange?
It would be.
It would be
far above the average.
Yes. Yes. They're so far above the average. Because a group of 40 people, shouldn't their average be close to the real average? It will be harder for a group of 40 people to be further away from the average. Doesn't that tie into the whole idea of the standard deviation gets smaller? So do you see how the standard deviation gets smaller exactly by the square root of the sample size I picked? So the bigger the sample is, the smaller my spread is, which makes sense. What if I took 800 people, right? What's probably that their average height is over 6 foot tall? I'm like, that's 0, damn. I'm gonna have to pick some short people in there, right? It should be crazy unlikely for their average to be more than 6 foot tall. So the spread depends on the sample size. Maybe not. All right. So let's do some concrete stuff. Was I done with that? I think so. Oh, one more thing. This is the thing where you're saying, if n is greater than 30, distribution becomes normal enough. All right, let's see if you guys appreciate this example. Let me see, what time is it? Oh, it's getting to be there. Oh man. I can sense people out there saying, man, I thought this was rough before. What has happened? All right, give me a minute. Let me show you what this is really going to mean to us, okay? Don't freak out yet. Don't go drop the course yet. Hold on. Let's see. Where are you? There you are. All right, here we go. So in unit 7, oh, I already unlocked this, I think. Yeah. In unit 7, I unlocked something called sampling distributions. That's what this is. Isn't this a distribution of samples? Right? I go take a group of 40 and another group of 40 and I distribute the groups. So this is a sampling distribution. All right, so let's look at this freaky handout that I've created. This is the most colorful handout and it's only 2 colors. Sorry, I'm really terrible with colors. So let's look at this thing. Let me open this thing in a better way again. Hold on. So you guys go access that for yourself. You could do it, Jeff. Can you? What was this called again? Oh yeah, sampling. There it is. Okay. This will be the last thing we talk about today. So just
Tell yourself it's going to be okay. We're almost there. Okay. So here it is. So is this distribution, so does this make sense? I put 4 numbers in a hat. To make this simple, this is not a continuous distribution, but is everybody cool with the fact that I can make the bars like this? So it goes from like 0.5 to 1.5. Remember doing that? Is this a normal distribution? Hell no. It don't look like a bell at all. What kind of distribution is this?
Uniform?
Uniform. Kick ass. I like it. It's a uniform distribution. Why does that make sense? Because I put the numbers 1, 2, 3, 4 in a hat and mixed it up. They each have the same likelihood of happening, right? Of me picking them. So of course it's uniform. Nobody is more likely than anybody else. You guys with me? Maybe? And do you guys see, why is this 0.25 tall? Because it's 4 across, so it'd be 1/4, right? Isn't each one have a 1/4 chance of happening? Okay, now. So the distribution did not start off normal, but is it a gross distribution? Would you say this is gross, like my original Florida was? Like the original picture I had up here was pretty damn gross. Is this gross? I don't know. You guys are like, what's your metric for gross, Jeff? I don't know. Is this like, or is it? So it's not normal, but it is already symmetric, isn't it? For one thing, almost, the simplest way to make something symmetric is just don't make it change at all. All right. So I'm trying to get you ready for this. What's going to happen is, all right, I'm going to take and I already did. We're going to take every possible sample of size 2 with replacement. We have to do it with replacement, so the probabilities don't change. So if I reach in and I pick out something, couldn't I get a 1 and then I drop it back in, and could I get the 1 again, for example? Correct? Yes. Doesn't this capture every possible sample of size 2? Yes? No? Okay. This is everything that could happen, correct? Now, in a situation like Florida, where I have millions of people and I was picking 20 people at a time, can you imagine how big this table would get? It would be insane, right? So thank God. So what I'm trying to do here is I'm trying to make a problem exactly the same as the Florida problem, but on a scale we can work with directly, right?
I have a quick question.
Yes.
So the 1s and then like the 2s and then like the 3s where they all go down, is that technically like the label for the sample mean?
Hold on. So we're gonna have to calculate. Where's that?
The sample, whatever. So like, how like when we had that problem and it was like fiction books or nonfiction. So it's like F 1, 2, 3.
Yes,
is
sure.
that what the 1s and 2s and 3s?
So this is a lot like that problem where you had to roll 2 dice. And if you did that correctly, you should have got 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6.
Now I see.
Yes. So this is every single thing that could happen, correct? So if I had listed all these together, that would be the sample space.
Okay.
Because these are all the things that could happen if I pick samples of size 2. I've listed everything that could happen. Yes?
Oh, okay. Yeah.
All right.
Now I get it.
Which is why we had to talk theoretically about Florida, because there ain't no way we're going to actually go get every possible sample of size 20.
Yeah, I think I was just a little bit confused because instead of being like one absurdly long chart, they like put it in the columns.
Oh yeah, and they is me, but yeah.
Now I see.
That's better to see. Yeah. So what's the data in the first place? What was the data right at the beginning of the problem? Right up here, what's the data? What's the variable? What's the values of the variable, which is the data? What would that be? Nothing too major here. What's the possible things that you pick up? Yeah, 1, 2, 3, 4, correct?
Yep.
1, 2, 3, 4. Just those individual numbers, right? Okay, now, what I'm trying to do now, and here's the picture of it, right? This is the probability distribution drawn out. So now I'm saying, okay, instead of using individual picks, I'm going to use means of 2 picks, and that'll be my data, right? Maybe. So instead of graphing what could happen when I pick one thing, I'm going to graph what could happen when I pick 2 things and take an average. So somebody help me out. This will be easy. What's the average of this sample?
1.
That's crazy. What's the, keep going. I don't know why there's no 1.5. So are you with us? That's 2, right? And that's 2 point, there's a nice pattern that happens here. This will be 1.5, and then you go up by half each time. You can check me on this, by the way, but I think we're all okay, right? And then it's gonna be 2 and 2.5 and 3 and 3.5. And then it's gonna be 2.5 and 3 and 3.5 and 4. So what's the least likely means to get? What's the least likely means to get?
One and 4.
1 and 4, right? 1 only occurs once, and 4 only occurs once. What's the most likely mean to get?
2.5.
2.5. It occurs 4 times. What was the mean of 1, 2, 3, 4?
2.5.
Holy shit. And by the way, real quick, do this for me. Anybody who can you go ahead and put in L1, put 1, 2, 3, 4, and see if you can verify this standard deviation here? Jeff, come on, dude. Right, you can do 1 var stats. You guys remember? Do 1 var stats. This is something you're going to have to remember because it's going to become a huge part of the class here. Well, in the summer, everything's soon. So soon. Do you guys get that same value? So let me show you. Let's see if past Jeff did this correctly. Shit and a half. Current Jeff can't do things right. What?
For these, we could just plug it into our calculators, or
Totally, yeah, please do. Please just
like
plug in the
no show
calculator.
work.
Plug in the calculator and just, yeah, especially when we're doing something like this, you can just plug in the calculator and get the answer. Let me do this so I can show you. 1, 2, 3. Has anybody verified that yet? So all I'm saying is, yeah, let me stop sharing. Put 1, 2, 3, 4. Hold on. I know. Hold on. I don't know if that's any better. Is that better? There we go. Put 1, 2, 3, 4 in there. Then, I still haven't corrected my poor little computer. Go to calc 1 var stats, right? 1 var stats. And then you want to tell it L1. And if you have an older calculator that doesn't even ask you these questions, that's fantastic. And then what do I get there for sigma? 1.118. Thank God. For a minute there, I was like, did I do it right? Is everybody with me? Anybody not with me? Oh, anybody don't want to tell me? Raise your hand if you're tired of me asking you. All right. So let's see here. Now, so this now is my data, not 1, 2, 3, 4, because that isn't necessarily what's going to happen. These are what can happen when I take 2 at a time, right? Everything in yellow is now my new data. So of course, what's going to have the highest bar now is 2.5, right? So of course that makes sense. Help me out. Does this look roughly normal?
Are we
Yeah.
supposed to be able to see your screen?
Oh shit. Yes, thank you. Oh boy, I got to tell you something. I have no idea.
Look normal, relatively normal.
Yes, real quick. I think I'm relatively good with technology, and I'm actually obviously not. I'm worried about my colleagues who are older than me. Some of them are not the greatest. But I'm pretty bad too, so it doesn't matter. So 2.5 occurs the most. It should be the tallest, and sure enough, it's the tallest here, right? And here's what I did, right? 2.5 occurs 4 times out of 16. Is that cool? Isn't my sample size 16 now? Okay, so that's how I got these probabilities. All right. Now, here's the neat thing. So this does look much more normal now, right? What was n supposed to be? N had to be greater than what in general to become normal enough?
30.
30. So how is this already looking normal, Jeff, Mr. Ooh? And I'm like, because 30 works for any distribution, no matter how ugly it is. Didn't it start off pretty already? Yes. It was already symmetric and all that. So after only a sample of 2, it's already looking pretty normal. You guys doing better out there? No? You're hating everything? Okay. So, and the last thing I want to say is that if you put all this information, remember that you could do the XP of X thing, right? If you did that, you would get a mean of 2.5. It's still 2.5. The mean is still 2.5. And the standard deviation would now be 0.791. Now let's check this out. What was sample size 2, right? So if I do this formula, I've got it written right here, but if I do this formula, 1.118 is what sigma was divided by the square root of 2. Where'd the 2 come from? Because sample size 2. I do get 0.791, which is what the new standard deviation is. The formula does work, and it does. I could make obviously it would be harder if I made a bigger sample size and all that kind of crap, but it would come out the same way. So what if I took samples of size 3? How could you figure out what the new standard deviation would be without doing all this crazy shit? If I took every sample of size 3, I don't have to do all this. You're not going to have to do all this, correct? This whole thing is just trying to show you that the formula works. That's all it is trying to do. So what if I took samples of size 3? How would you get what the new standard deviation is going to be?
It would be smaller.
True, but how would you get exactly what it's going to be? What's the formula tell you to do? So I would just take 1.118 divided by square root of 3. That would be the spread if I took groups of 3 at a time. What if I took groups of 11 at a time, divided by the square root of 11? All right, what time is it? I want to do, oh shit, we're like way late. Not really, we're early to be honest, but late according to me. I desperately want to show you, before you really freak out, what a problem like this is going to look like. Okay, hold on. I know it's late. I know. It's not really late. You're just spoiled. So just sit there and wait. Hold on. Here we go. I'm not even going to activate this yet. I'm just going to show you this. So what's going to happen is, look at this problem. Here's the bone density problem. Okay, we're not going to do this problem right now. I just want to point this out. Part A is if we randomly select one woman. Is that greater than 30? No. But why is it okay? Why can I still do the problem? Because I tell you right here, it already is normal enough, right? So I don't need n greater than 30. It's already normal, correct? I get a lot of people freak out about that, but all of chapter 6, we were taking one thing at a time because it told me it was normal. Now, part B says, so real quick. Oh, you guys hate me already, so it's okay. Up here, I would do this. I would put 2.9, right? Because that's the mean. I would put more than 3. I would put a 3 there. I want more than 3, and I would make a z-score, correct? Woo! Down here, do you see how that's almost the same question? More than 3, right? But the difference is I'm talking about a sample mean of a sample of 22. So what's the very first thing I do when I see take a sample and it asks about the sample mean? The very first thing I do is I change the standard deviation. So when I go, the picture's going to look the same. Well, it should anyway, this one. And I go to make a z-score. When I go to make a z-score, I'm not going to use the standard deviation here because that's the one that works for individuals. I'm going to use the new one. I'm going to use this one. What was it? 22. I'm going to use whatever this standard deviation becomes for a group. That is the one difference. That's it. So instead of dividing by 0.31 to get a z-score, I'm going to divide by whatever the shit this is to get a z-score. That's the only change in your work. You understand? So everything I talked about today was just concept. Why? And then here's the nuts and bolts. It barely changes anything, right? Well, I got a chat coming at me. Yee, somebody says, okay. Holy shit, that's enough, guys. I'm sorry. I at least wanted to show you this. So the nuts and bolts of how this is going to affect your work is barely at all. So when you see me take a sample and ask about the sample mean, you know you have to change the standard deviation. Oh my God. So I think this would be my lowest rated IMDb class. But that's enough. That's enough for today, obviously. Let me know if you have any questions. Otherwise, go away and then come back tomorrow. Everybody, you guys okay? Have I fried your brains? Any questions? You guys all right?
I have a question, and it's only because I don't get how you got the standard deviation in the beginning. Like, how did you verify that?
Oh. Wait. We're talking about that the colorful handout thing?
Yes. So the 1.118, how did you end up verifying that?
All right. So all I did, let me pull this back up. I put it into list one and it had one var stats.
Oh.
Yeah, that's all I did. So I just put 1, 2, 3, 4. I could have done XP of X and all that shit, but that's a long ass way to get to the so why can I do it just 1, 2, 3, 4? Because aren't they all equally weighted?
Yeah.
All right. So I can just throw it in the 1, 2, 3, 4 in the calculator and it'll tell me this.
Okay, that makes sense.
That's what I was trying to show you. I got to work on my calculator emulator on my computer. And then down here, this one, I could in list one put 1, 1.5, 1.5, 2, 2, 2, 2.5, 2.5, 2.5, 2.5. Are you with me a little bit?
Mhm.
Do I have the actual? Yes, I do. Why am I being so silly? Here. So if you don't want to do the XP of X shit there either, and I wouldn't blame you, you could just put in your calculator all these numbers. Put all those numbers in list one, and then do one var stats, and it will tell you this.
Oh, okay.
And that is what the old standard deviation is divided by the square root of 2. Why 2? Because we took samples of size 2.
Right. I got that part. Okay.
So if I took samples of size 3, thank God. Would you want to do all this work for every problem? No. So thank God we have a formula that will tell me what it would be if I did do all this work. So I'm just not going to do all the work. I'm just going to use a formula now to figure out what the spread is. So obviously,
down a little bit.
Sorry, what's up?
Could you scroll down a little bit? I was just trying to take notes on the last page.
Oh, this is it. I mean, this. Oh, you mean go back to
No, not this. It was about like
the bone density.
the formula. Yeah, the bone density one.
Right. What I wrote down there didn't stay. I'm sorry. So we're gonna work on that handout tomorrow. Yeah. Yeah, and I figure most of you guys are probably not ready for chapter 7 homework anyway. So we have some time for me to show you more examples tomorrow. Yeah. Anybody else questions? Again, we just learned this. We just talked about it. So allow yourself some time to work with it before you beat yourself up for not understanding it. All right, I'm going to head out. I don't see any questions from anybody. Okay.
Thank you.
Sure. Bye, everybody.